Okay, we want to simplify those radicals. So let's see 61. Well, 3 radical 48 divided by radical 12. So let's first understand what does this radical mean. Okay, usually here we have the index. So if this have no number, that means the index is 2. Let's see if we have this y equals to square root of x. So that means y squared equals to x, right? So that's what it means. Let's use an example. Let's see square root of 12. If this equals to y, that means some number squared to be 12. Right, some number squared to be 12. So if we have y, if we square y, we square this, of course, we get 12. So that tells us square root of 12 times square root of 12 is 12. All right, so that's what square root sign means. And of course, this index can be any number, can be cubic. Right, if we have a cubic of x equals to y, that means y cubed equals to x. Okay, so first let's understand it. So this is the meaning of square root. So this is square root of 48. That means some number squared to be 48. Right? But this 3 is the 3 we know. A square root 12 is square root 12. That means a number squared is 12. But when we have, say 48 is square root, 12 is square root. So we can put those two numbers together. We have a 3, so this 3 should be big 3. Multiply by 48 divided by 12. So we can put 48 and 12 under the same radical sign. In this case, we can simplify it because they have a common factor. Oh, actually 12 goes to 48 how many times? 4 times, right? Because 12 times 4, that's 48. So that becomes 3 radical 4. And we know radical 4. Radical 4 is 2. Because the square root of 4 equals to x, that means x squared equals to 4, right? So 3 times 2, which is 6. So this whole thing, when we simplify, afterwards equals 6. Let's see 63, 65. Let's go vertically. Okay. Same thing here. You know, the index is 2. The index is 2. We can put them under the same one. So we get 45 divided by 80. Because once we put them under the same sign, we can perform cancellation. So first, let's divide by 5, right? Because 5 is a factor of 45. 5 is a factor of 18. 45 divided by 5, we get 9. 80 divided by 5, 16. Right, because 5 times 16, that's 80. Now, square root of 9 is 3. Square root of 16, that's 4. So we get a 4 over 3. Let's say 65. 65, we observe. Even we put square root 3 and square root 5 together as square root of 3 divided by 5, it wouldn't help us, right? Because 3 and 5 doesn't have common factors. So what do? We multiply square root of 5 divides itself. We always do this, right? We always multiply by 1, but a 1 is a transformer, just whatever we need. In this case, we need a square root 5 in the denominator. So we make this 1 square root 5 divides itself. Now square root 5 times square root 5, that's 5. So 3, we have this radical 3, this radical 5, 3 times 5, 15. Or sometimes we write as this 3 over 5 of, we write square root 15 on the side. Because square root 15 is an irrational number. sometimes we're treating irrational numbers as variables, because we know this number is between 4 and 6. I mean, right. Anyway, so now between 3 and 4, right? Because 15 is less than square root of 16, is greater than square root of 9. So it's between 3 and 4. Square root of 15 is between 3 and 4. Now let's see 66. 66, we're going to do the same thing. We multiply by square root of 2x in the numerator and in the denominator. Once we do this, we get 2x in the numerator, in the denominator, we get x square root of 2x in the numerator. Now we see we have x as a factor in the numerator, we have x as a factor in the denominator, those two canceled. So we have square root of 2x divided by 2. That's the simplified version. Now let's go to 62. So this is addition. Addition requires like radicals, like terms, right? You know, before in polynomial, we call like terms. If you have like terms, we can combine them. So similarly, if we have like radicals, we can combine them. Like radicals, like 2 radical 3 and 5 radical 3. That means the number and the square root are the same. So here we have square root 3. Here we have square root 3. So what do? If we add those two, we just add 2 with 5. So we would get a 7 radical 3. Right? Those are called like radicals. So here we have 3 radical 5 plus 2 radical 20. Looks like we don't have like radicals. But remember, 20 can be split as 4 and 5. So square root of 20 is square root of 4 times square root of 5. And square root of 4 is 2. So that's a 2. Square root of 20 is 2 radical 5. And then we have this 2. So 2 times 2, that's 4 radical 5. So 2 radical 20 is 4 radical 5. Then plus 3 radical 5. We did have like radicals. So the like radical is square root of 5. And we have 3 of them. We have 4 of them together. We're adding them. We have 7 of them. All right, let's see 64. Square root 7, square root of 8, square root of 49. Well, square root of 49 is just 7, right? Because 7 squared is 49. Right? So this is 7 squared. The power and the index are the same. So they cancel each other. So we just get a 7. And square root of 8, again, is square root of 4, square root of 2. Square root of 4 is 2. 2 times 6, that's 12. So square root of 8 is 2 radical 2. And times 6, that's 12 radical 2. And plus 4 radical 7. And that's it. So this is, we cannot simplify further. Because here we have radical 7, the first term. The second term we have radical 2. And the third term is just 7. So we don't have like terms here. Cannot be simplified further. And that's it. All right, so let's simplify radicals.